Good morning, everyone. Thank you for attending my session. My name is Ben Weber, and I'm a distinguished data scientist at Zynga. Today, I'm going to be talking about how we've opened up our PySpark platform to our entire analytics organization and some of the novel applications that have resulted from using this approach. So it's aligned with the theme of the conference, which is really democratizing tools and platforms. And we've done this at Zynga. We did have some challenges with kind of scaling and growing, but we'll talk through about how we've kind of overcome some of those hurdles and provide some best practices for scaling things like this at your organization. So before digging into how we're using PySpark at Zynga, I did want to talk about one of the initiatives that we've been a part of recently with COVID-19, which is we partnered up with the World Health Organization as well as a few dozen other game studios to basically spread messages around social distancing through the games which we have as a communication channel. So we led this initiative called Play a Part Together, which was really about kind of amplifying the signal of how to stay safe during this time, how to keep connected with people, but while also being safe in this unprecedented time. So this aligns with our mission of connecting the world through games, and it's something that I'm proud to be able to mention that Zynga has been a part of. So today we'll talk about basically how we've opened up the PySpark platform to our full analytics organization. Now the way it works is basically everyone within the analytics organization at Zynga, which is over 50 people now, can get hands-on with PySpark through the Databricks platform that we're leveraging. We'll talk about kind of how we've scaled up and how there's been some challenges with adoption and really getting more people hands-on in some of the tooling and kind of materials that we had to put in place to really get this adoption scaled up. And we'll talk about some of the kind of challenges we faced as we did that as well. To make it manageable, we'll talk about some of the trainings we put in place as well as policy so that it's not a Wild West in terms of this platform, but it's something where teams can effectively collaborate and kind of partner across teams to build novel applications. So I mentioned that basically by opening up the platform to a broader team, we're actually seeing people use it in ways that we hadn't expected with just the initial smaller team that we started with. So that's kind of one of the key takeaways, which is that kind of opening up the platform has really resulted in interesting uses of it because more teams are using it for different types of problems. So it's been great to see what teams have been able to accomplish with it. So the agenda for today is first to talk about mobile game publishing and kind of the function of an analytics group within this type of organization. We'll talk about how we opened up the platform and some of the challenges we faced. We'll then talk about some of the lessons we learned from it and how we've actually scaled it while maintaining cost and functionality. And finally, we'll look into some example applications we've built out through the platform. So to start, we'll talk about mobile game publishing. If you haven't heard about Zynga, we're a mobile game publisher. We have studios located in over half a dozen countries. And a lot of the headquarters is based out of San Francisco in terms of the publishing function, which is really centralized functions, things around marketing, around legal, around corporate development. And it's something that kind of supports our studio. So basically our studios are embedded throughout the world, and then we have kind of a strong publishing function that helps those studios operate. In terms of the portfolio of games that we have 6 and more recently 8, as we announced yesterday that we are actually acquiring Peak Games, which will bring Toy Blast and Toon Blast into our collection of forever franchises, which are games that make over 100 million annually and games that we expect players to engage with for several years. So one of the interesting challenges we face is that we have these kind of embedded analytics teams that have different types of data sources that they're working with. And we're collecting different types of events for all these different games. So that's one of the challenges we face is we've centralized the tooling for collecting the data, but the analysis and kind of the findings that teams have varies quite a bit given based on the telemetry that teams are collecting. So we have casino games, social slots games, Wars of Friends, as well as racing games and a collection of different kind of merge and match mechanic games. So it's great working across a broad portfolio of titles in order to basically find insights for our game teams. In terms of how Zynga Analytics is structured, we're actually a combination of two disciplines where there's the analytics discipline and the engineering discipline kind of within different parts of the Zynga company, but we're essentially one organization, which is a mix of the analytics, data science, and analytics engineering teams. So we have embedded game teams where they're actually co-located with the game teams and working with product managers and studio leadership, really on understanding the launches of games, running the business metrics, as well as any kind of ongoing experimentation, and really tuning features and kind of working with improving the life cycle of games. There's also a central analytics function, which I'm part of, which is supplementing our publishing platform, which is doing things like improving our marketing efforts and being more efficient with our spending across user acquisition, and supporting kind of initiatives that are across the portfolio of games rather than specific to one game. And then we have our analytics engineering team, which is responsible for building and maintaining our data platform, which ingests data, provides data lakes and data warehouses, as well as kind of endpoints for game services to call to provide real-time personalization. So in terms of some of the functions that the team actually performs, there's a few that we've done for quite a while, and some newer features that are becoming more prevalent as we've built up our capabilities. But the first is really insights for our game teams. So this is analytics and reporting, the standard kind of business intelligence kind of pipeline that you need to understand, run the business metrics, as well as understanding different parts of the gameplay experience. So this would be looking at the funnel of new users and understanding kind of where we can tune the first-time user experience. This would be basically understanding kind of the impact of features that we've launched and working with product managers to determine how to roll those out. One of the key functions we've really talked about a lot at Zynga in the past is kind of this focus around experimentation. And we have a standardized platform that allows product managers and analysts to set up experiments that then can go live in our games. And we've already kind of democratized the experiment side of Zynga. And we're opening up other tools as well now. So there's a lot of practice around experimentation that we've used to basically tune our games over time. But what we're doing more recently is actually building out personalization services, which are using machine learning to optimize gameplay or other kind of features or tunings within games based on kind of feed that we're collecting from players. So this is things like using reinforcement learning to understand when to best send out notifications for players. And this is where we're really kind of leveling up our tool stack and allowing our analytics team to work more closely with our engineering team on these really interesting platforms. And another key function of the publishing platform is essentially marketing optimization, where user acquisition is a big part of any mobile game publisher. And this is something where we want to make sure that we're leveraging tools to be sophisticated in building out these kind of automated workflows. So our platform has evolved over the years. Since Zynga launched its first game in 2007, there's been a big focus on using a data warehouse to basically track metrics in games and kind of find the results of A/B testing. So that was really the bread and butter of Zynga for over a decade, and still continues to be a core foundation in terms of what our analytics function is performing. This has mostly been working with SQL clients and kind of just running queries directly against our data warehouse. We've done a little bit of kind of scripting and regression modeling with R or other programming languages, but we didn't really have standardization. It wasn't until about 2017 that we've really changed to a new era at Zynga, where I am phrasing this as the notebook era, because we started aligning on Python as the standard language that we wanted to use. And most analysts are spending most of their time now in Jupyter Lab rather than SQL clients or just working with flat files. It's also a time where we started using GitHub for collaboration. And we actually use that Jupyter Lab environment to have a standard ecosystem where all the libraries are the same across the environments that our teams are using, so that there's much less problems in terms of sharing notebooks and having the ability to run notebooks on different machines. So it's been a great way of actually standardizing on the tools so it's easy to collaborate and share. And then where we're at now is what I'm calling the production era, which is really scaling up to large data sets using Apache Spark, but it's also putting data products into production. So this is standing up web tools that other teams at Zynga might use. And it's also partnering with our engineering team to set up things like model endpoints, where we're using machine learning and reinforcement learning to actually have these personalization services that game teams can leverage for their products. So that's an overview of kind of the Zynga publishing function. What we've changed kind of over the 2 years that has really made it kind of democratized versus restricted is our platform was initially restricted to a small set of data scientists, and it was more of an opt-in approach in terms of getting access to the platform so that you could actually build out tools. About 2 years ago, we've changed how that worked, and we basically made it so it's no longer opt-in, but basically everyone has access to the platform. And then we hope to make sure that people use it in a reasonable way. So this is where we wanted every team to actually be able to build data products. But as a result of that, you have teams that need to maintain and kind of have more ownership of these data products. So it's kind of a trade-off in terms of, it was a great way of having standardization because everyone has a shared platform. And with Databricks, there's these great collaborative notebooks. But it also means that we need to keep an eye on what's going on so that there's not too many clusters that are provisioned and costs don't get out of control. So in terms of why we wanted to open up, there was a few motivations for doing so. One of the key ones was really kind of leveling up the skill set of our team. So we wanted a path for career progression so that analysts could transition to the next levels and kind of understand more of what we had traditionally aligned with kind of the data science discipline. And we've kind of merged those in a way where a lot of uh, issues that were kind of data science specific are now being encountered with our analysts as well. Things like doing some regression modeling or working with significance testing for results. So it's a way to allow our team members to get hands-on with that. One of the big motivations also was basically standardizing the tooling. So we had Jupyter Lab as kind of a exploratory notebook environment, and we wanted a kind of production environment. So we basically aligned on PySpark as the place to do that. And we wanted to evolve our data platform so that we could actually scale to large scale data sets. We both have use case for kind of ad hoc large data set processing, as well as kind of model pipelines, whether those are batch pipelines or pipelines that produce coefficients or other model outputs that are used in real time. And we wanted to make sure that we had a platform that could scale to all those different use cases. And I already mentioned kind of large scale data processing where we often have to kind of turn around terabytes of data quickly where it might be in flat files and we need a way of just spinning up clusters to process that. But we also have tens of millions of daily active users. And if we want to make machine learning models based on that, we need to be able to do so in an efficient way. And then the final point is we also wanted to build distributed ownership of some of our data products. So we previously had an approach where there was kind of a handoff where an analytics team would hand off kind of a prototype model to an engineering team to take it to production. We now have a platform where for a lot of use cases, the analytics team can own that as a self-service model end to end. So the first challenge we faced was really around adoption of the platform where um, we didn't really have many materials around kind of how to ramp up on PySpark or kind of the fundamental differences between PySpark and working with Pandas data frames. So we first started by setting up some training notebooks that basically showed how to do things like load in a data frame from a data lake or data warehouse, save the data frame to different outputs in our data platform, as well as kind of standard operations like working with columns, dropping columns, kind of a lot of standard operations within Pandas. And we also just set up some documentation on the platform itself and kind of how to get started on Wiki. And that was kind of a set of kind of onboarding materials. We've also done a bit of mentoring where we started with some uh, office hours where we set up basically weekly sessions for people to come in and kind of learn about the platform. And this was great kind of at the start of trying to ramp up with adoption, but we found less interest in these over time and then switched to more of a kind of one-on-one or kind of team mentoring process. Related to mentoring, we also have had kind of an annual analytics event where we do a lot of trainings and kind of ramping up on PySpark has been a big focus there. But more recently, where we've seen a lot of uptick in adoption is really when we have kind of cross-team projects and more collaboration. So I've mentioned our analytics team working with uh, our kind of analytics group. And the partnership between analytics and engineering has been great, where we've actually seen things like reinforcement learning being used as kind of prototype library in Python, but then our engineering team being able to leverage a production system they've built. And it's kind of helped accelerate the learning curve for some of the analysts there, which has been great. So in addition to that, we have kind of more eyes on these notebooks that are being used for critical processes. So it's a way of giving feedback to team members that's been really useful. Also to accelerate kind of this adoption, we've looked at using some of the features of the platform, which has helped people feel comfortable in the environment and be able to kind of leverage existing tools more easily. So one of the things I've used quite a bit is Pandas UDFs, which allow you to basically do a divide and conquer approach where your data frame gets split up, sent to different worker nodes, and then you basically write a function that operates on it as if it was a Pandas data frame. I mean, we've used this to do things like automated feature engineering on large scale data sets, and use tools like XGBoost in a distributed way, even though the core library is not developed for PySpark specifically. And there's a session on this from Zynga last year where we talk about the system we've built that uses this approach at scale. There's some features in Spark 3 that I'm looking to see in terms of making these more efficient. We've also explored the Koalas library to try to provide an intermediate step between Pandas and PySpark data frames. It's been useful for kind of getting hands-on with some of the basic operations, but we haven't seen kind of immediate success with just trying to port existing code from Pandas to PySpark. But as more of those functions get implemented, I think it'll be a nicer way of kind of having an intermediate step between Pandas and PySpark. The other thing I've mentioned is ownership of data products. And this has really been useful because as we've scaled up to more products, we have more teams that are now responsible for owning them. So it's not just one kind of engineering org that's responsible for all these diverse projects, but the people that know the intricacies of them are really responsible for continued kind of maintenance and monitoring of the platforms. So we generally have two paths to production. There's essentially model pipelines, which tend to be batch models where we basically have Databricks jobs that run, that source data from the data lake or data warehouse, and then publish it to a data sink, such as our Couch-based kind of real-time applications. And this is something where the results can be served through experimentations, our experimentation platform, and be used immediately by game teams. So this is where analysts and data scientists can actually kind of own the model end to end. The other way we work with kind of models is through model endpoints, where we'll partner with our engineering team to use AWS SageMaker for machine learning models. And more recently, we're using an in-house library built on TF agents to actually serve reinforcement learning models. In this case, it's more of a shared development pattern, but we've actually seen a lot of useful collaboration in this space. So I mentioned some of the challenges we faced, but we'll dig into some of the learnings we've had as well and kind of how we kept things in check so that as we scaled up the number of users, we didn't kind of have uncontrolled costs and other issues. So one of the things we did similar to the Jupyter Lab ecosystem is we created a library with kind of standard functions for common tasks that our analysts or data scientists will want to perform so that it's straightforward to load a data frame or push a data frame to our application database, as well as work with some of the other tooling in our ecosystem. At the time, we had some functionality that was similar to MLflow for doing things like monitoring models. And over time, we're actually deprecating a lot of that functionality and switching to MLflow itself. But it was something that was really useful to get kind of up and running with the platform. And we have some other functions for orchestrating through Airflow or kind of doing kind of communication through jobs as well. So it's been a great way of getting kind of the adoption curve ramped up. One of the issues we ran into as we scaled the number of users was the need for more and more libraries, and we found conflicting library versions. We found some issues with Tornado that were really challenging to debug during cluster startup. So as a result, we basically came up with an approach where we have a fixed set of development clusters with set library versions. And then we have any jobs that run on a regular scheduled to run as ephemeral clusters. So there's not conflicts between different library versions. And then we roll out new development clusters as major software releases are available. There's also the ability to spin up clusters if a set of specific libraries are needed for a team or project, such as the feature tools library that we were using for the Anomaly project. And then in terms of job ownership, we've had issues with people leaving teams or the organization. And then you have these jobs that are running that don't have clear owners. So we had to set up a set of processes to make sure that that results in not an overwhelming number of jobs over time. So the first thing was to have backup owners for jobs and kind of map these to teams rather than individuals. We also monitor the outputs of these jobs to see if they're actually being used. And if there's a large window of inactivity, then we'll flag it to be sunset. And then jobs that we run regularly that we've seen successful will actually migrate to Airflow, where we have kind of more eyes on the kind of DAGs that are actually in production. And then we've also built data products that work across multiple games rather than building a lot of game-specific models, which means that we just have a smaller number of pipelines that we need running each day. And then the final lesson was really around cost tracking, where we scaled up a lot of clusters and people wanted to do things like look at ramping up GPUs. In order to keep costs in check, the main thing we had to do was make sure that we had good tagging so that in the AWS ecosystem, we could have good kind of management of which projects were basically running up costs and making sure that we were able to work with teams to optimize their jobs and make sure that they're using the correct instance types. So this is something where we just needed the tooling in place to do this effectively. There was a lot of challenge in just kind of ramping up usage and kind of people kind of going wild on the platform and trying to learn what to do. We set up a Slack channel for general questions, and this worked well for the majority of users, but we often had issues where people were kind of asking an overwhelming amount of questions, and we wanted to basically avoid that so the team kind of managing the Slack channel wasn't overwhelmed. It was useful, however, for some kind of non-trivial issues we found with like cluster startup, where we found some kind of common issues that were worth addressing in a more broadly way. Basically, to approach this, we did set up some kind of SLAs around kind of responding to questions or just kind of cluster issues. With the team being distributed around the planet, we want to make sure that people weren't waiting over a day for kind of responses to the things. But generally, the way this has been resolved over time is to have more people familiar with PySpark and being hands-on that can answer questions. So it's not just one kind of single Slack channel, but we can have kind of team-specific PySpark channels as well. So we found that actually just as you kind of have more people ramped up with the platform, that they can ask and answer questions for more of the team rather than kind of going through one single source for answers. So this is where we've really been kind of trying to pair up more kind of cross-team projects to develop knowledge and kind of ramp up the skill set of our individual teams at Zynga. So as I mentioned, we've opened it up to kind of our broad organization of over 50 people. And what we found is people had kind of specific use cases, but there was a lot of findings that we were able to generalize and actually use across multiple games and across the central functions. So we'll talk through a few examples here. The first one is the system called AutoModel, which I presented at Spark Summit last year, where we're basically building hundreds of propensity models daily. So trying to predict which users are likely to churn or which users are likely to purchase. And this is published to Couchbase, where our game teams can set up experiments around it and try to tune different features. So this was a great way of actually ramping up end-to-end kind of self-serve pipeline, where we found that it was actually used for ad targeting as a potential use case. So that was more novel on the actual application, but some of the other applications we found were quite interesting as well. So one of the things we've talked about quite a bit at Zynga is really this idea of player archetypes, where you have people that kind of have different types of gameplay behavior. And you can kind of define archetypes by doing a clustering exercise or basically some sort of user segmentation exercise. We found both our team in India as well as our team in SF were actually looking at similar problems across different games, and we're actually relying on kind of a standard approach where we basically look at k-means clustering as a way of coming up with different player archetypes, where we also had a novel application which was around kind of marketing, where we could do different targeting based on different player archetypes. So that was an application that wasn't kind of initially intended with this project, but something where we've actually found useful results from being able to scale up archetypes to more than just one game. Another project that started actually as part of a hackathon we had at Zynga was this idea around cheater detection, where we wanted to use an autoencoder to basically compress the gameplay behavior of a user and then kind of decompress it to see how well we could actually kind of come up with a model for describing kind of activity in a latent space. And the general idea here was that players are represented as a one-dimensional image, and you use an autoencoder to compress and decompress it. And where you see large discrepancies between the input and output, we can actually evaluate those data points and see if there's some sort of activity that looks suspect. So this was something where our team was using TensorFlow, and they were able to ramp up kind of large instances to use TensorFlow on the platform, where we previously wouldn't have access to those types of compute resources. So it's a great way of actually just spinning up large scale kind of Python workflows as well. So that's one of the great ways that opening up this platform has really benefited some of the work that we're exploring. And then also economy simulation is a big part of just mobile game tuning, where we want to understand how like a change in our gameplay or adding a new feature will impact the economy or having some sort of different daily bonus. And this is something where our team based out of Austin was able to represent kind of Markov chains as data frames, where you basically have kind of a data frame with state for each user, and you run it through different transition states. And by doing this in an iterative way, we were able to actually simulate adding new features or kind of tuning the game. And this was a general approach we were able to apply to other games as well. So it's one of these great approaches where we wrote it once, but then could scale to other titles. Experimentation is also a big piece of the analytics function at Zynga. And we've been able to use PySpark to actually scale up to larger data sets that we're doing things like significance testing with. And this is really where we're leveraging Pandas UDFs for divide and conquer approaches. And it's allowed us to do distributed work with SciPy, NumPy, and stats models. And then one other novel application I'll call out is really our work around reinforcement learning, where there is a talk about this at the summit as well, where we now have a real-time model serving pipeline for reinforcement learning, where we can do things like understand the best timing for sending out notifications to players. And we've used this in both Words with Friends 2 and CSR Racing 2. So it's in production with large user bases. And it's a great way of actually showcasing reinforcement learning being used with a large user base. So we've actually open sourced part of this pipeline. It's called RL Bakery, and it's available on GitHub. And if you're interested in more details, please do check out the other talk at this summit. So I've covered some of the novel applications of PySpark at Zynga, and it's been great seeing some of the applications that our teams have produced whenever we've opened up access to this platform. So we've talked about some of the ways we've had to control cost and kind of make sure that library versions aren't conflicting. But the result has been great. We've seen really useful kind of outputs from opening up the platform. So to summarize the findings from basically the session today, I would say the first thing was that it was great to actually open this up to our analytics organization for large-scale adoption. It's something where you need to have some policies in place so that your team is able to adopt it and kind of ramp up on the platform. But it's basically a great way of having kind of a standardized platform where it allows for more collaboration and sharing of work. So to get to kind of the critical mass of adoption, we needed to have some training materials and hands-on support. But once we had a number of experts within different teams, it was much quicker to ramp up. And it's been a great way of kind of leveling up the skill set of the analyst at Zynga. Other than that, the main takeaway is that you'll find teams building stuff that wouldn't have otherwise been discovered. So it's been great to open up the platform at Zynga. And with that, thank you for viewing the session. You can find me at BG Weber on GitHub, Medium, and Twitter. And I also have the job site for Zynga available if you're interested in more about analytics at Zynga. Thank you.